Applying byte pair encoding to out of vocabulary words. Let us review the step-by-step procedure we followed in the previous video for representing out of vocabulary words. Step 1 involves the splitting of the out of vocabulary word into its characters after appending the /W. The second step computes the frequency of occurrence for a pair of characters or character sequences in the word. The third step selects the pair present in the learned operations. The fourth step merges the most frequently occurring pair of characters. In the fifth step, steps from 2 to 3 until merging is possible is conducted, which means a repeated number of iterations is carried out. In the previous video, we saw how 10 iterations were carried out. Implementing tokenization by byte pair encoding in Python. In the step 1, as we saw, we split the out of vocabulary words into characters after appending the /W. The Python code for the same is as follows. The step 1 is reading of the corpus. We first import the pandas library and then read the CSV file. We first import the pandas library here, then we read the CSV file as the next step. Then we convert the data frame into a single list. So we initialize this list as corpus and we run a for loop, splitting the tokens. Notice how in the previous few videos how we discussed that the token, if for word tokenization takes place as soon as there's a gap. Take the words reading corpus for example. As soon as there's a gap or a white space in between the two words, the two words are split up into tokens. The same is applied here. Token equals a rows of 0 dot split splits the first row on the occurrences of the white spaces. And another for loop is carried out to add these tokens into the list called corpus we initialized earlier here. In the second step, text preparation is done by us. The words are tokenized into characters in the corpus and appended with a /W at the end of every word. We initialize vocabulary or vocab as list and set of all spaces and joining all the words in the corpus. And then we remove all the white spaces. We then split the words into characters and then append the /W to each token that is created in the corpus. Step 3 consists of learning the byte pair encoding or computing the frequency of each word in the corpus. We import the collections package and then find the frequency of each word using the keyword counter. Then we convert the counter object into a dictionary and print the corpus. The output formed is as follows. Notice how in the previous video we saw a table in which a pair of words and its frequency is observed. Similarly, through this code we can find out the frequency of the sequence of characters. We notice that the word low occurs 5 times, lower occurs 2 times, newest occurs 6 times, and the word widest occurs 3 times. Let's define a function to compute the frequency of pair of characters or character sequences. It accepts the corpus and returns the pair with its frequency. We need to return a function that accepts the corpus and returns the frequency of each pair. And we define the function as getStats and input the corpus which we had initialized and stored where we had stored the token previously. We form pairs here by using the function collections.default dict. For word or and frequency inside the corpus item, we split the word, and if for a token existing in the length of symbols, the symbols contains each words which are split up, and take a note that the words are split up until length -1. This is because the list of characters begins, the first character begins with the ID index of 0, and hence for n characters, it's n-1 as the last character. The pairs are formed for all the characters and its frequency is added to it. Now the next task is to merge the most frequently occurring pair in the corpus. We will define a function that accepts the corpus best pair and returns the modified corpus. We import the regular expression library. Then we define a merge vocab function, giving the input as corpus in, which is basically the corpus we had stored where we had stored our tokens previously, and the pair or the sequence of characters. We initialize corpus out as an empty and we initialize bigram as joining the pairs of characters. We recompile this by using the start symbol and the end symbol, the bigram in between. For the word inside the corpus in, which was where our word tokens were stored in the corpus, we join the pair of words, and we in the corpus output we store for that index we store the corpus, the word in the corpus, which means that the particular index of the corpus output contains the word at that particular position in the corpus we previously stored it in, and this is given as the output. Next, it's time to learn byte pair encoding operations. As byte pair encoding is an iterative procedure, we will carry out and understand the steps for one iteration. Let's compute the frequency of the bigram. We run the function getStats for the corpus and print the pairs. The corpus was the getStats was the function we previously declared. As we see here, this is the getStats function in which the input is given as corpus, and the output is the occurrences of the pair of characters. DE occurs 3 times and so on. Remember how in the previous video we noticed that the pair ES occurs the most number of times, that is 8. In the first iteration, this can be observed. After printing the pairs and their frequencies, the most frequent pair is selected. Pest equal to max pairs, comma, key equal to pairs dot get. This function finds out the most frequently occurring pair. Most frequently occurring pair. So as we saw in the previous output, the most frequently occurring pair is ES, which occurs 8 times. And it's printed out as the most frequent pair, ES. Finally, merging the best pair into the saved vocabulary, we merge the vocabulary from the best pair to the corpus and print it after merging. We then convert the tuple into a string and append it to the list and the vocabulary. We append the best pair into the we merge the best pair into the vocabulary. After merging, we see that the next list of set of words are as follows: low, lower, newest, and widest. Notice how wherever ES occurs, it's given together because ES is now considered as a single character. We follow similar steps for certain iterations. We follow the same number of steps, the same steps for 10 iterations here. And after 10 iterations, the byte pair merge operations gives the result as follows: ES, EST, EST /W, LO, LOW, NE, new, newest, followed by /W, low /W, followed by /W, WI, WID. Applying byte pair encoding to out of vocabulary word, we see how to segment out of vocabulary word into subwords using learned operations. Consider out of vocabulary word be lowest. Applying byte pair encoding to out of vocabulary words, we consider the out of vocabulary word as lowest. We tokenize it into characters and then we append the /W, demarcating the end of the word. And then we create a dictionary by seeing the frequency of that word. Applying byte pair encoding to an out of vocabulary word is also an iterative process. We implement the steps as discussed earlier. This was the code which we previously used. We find the number of frequencies by using the getStats function defined earlier. We pair the characters and then we merge the indexes. We find the best or the most frequently occurring set of characters. We merge the best pair to the out of vocabulary word, and then we iterate this process for the number of times required by the user. This is the output formed after n number of iterations. After first iteration, the output is lowest. Before the first iteration, the word is LO, W, ES, T. Lowest is the 6-character word, which is the original token. But then after the first step, we notice how the /W gets added. And after the third step, we notice that ES is the most occurring pair or sequence of characters, hence it's merged, as we see here in the first iteration. LOW and ES is considered as a single character. In the next iteration, we find that EST is the most occurring sequence of characters, hence EST is considered as a single word. In the third iteration, it remains in the third iteration we notice that EST and /W is the most occurring sequence of characters. Hence, the second half, that is EST/W, is considered as a sequence of characters. In the fourth iteration, LO is considered as a pair of characters. In the fifth iteration, LOW is the sequence of characters. As you can see here, the unknown word lowest is segmented into two words, low and est. Low is the root word and est is a suffix word. This was application of byte pair encoding to out of vocabulary words. Thank you.